Hello everyone. In previous lectures, we have discussed the continuous time systems and discrete time systems, linear systems and nonlinear systems. In this lecture, we will discuss time invariant systems and time variant systems, causal systems and non-causal systems, stable systems and unstable systems. First, we will discuss the time invariant system. If a time delay or time advance of the input signal leads to an identical time shift in the output signal, the system is termed as time invariant system. The characteristics of the system does not change with time for the time invariant system. For the continuous time system that is initially at rest, we can express it in this equation. If the input signal is time shifted by t0, its output signal is time shifted by t0. The system is the time invariant system. Similarly, for the discrete time system, we can get the similar equation. If the input signal is time shifted by n, the output signal is time shifted by the same value, n. Here is the graphic expression for the time invariant system. If the input signal is this x of t, we get its output signal y of t. When the input signal is time shifted by t0, its output signal is time shifted by the same value, t0. Now we'll discuss the time invariant property for the resistor system. This is the relationship between the input signal and the output signal for the resistor. If the resistor resistance R is a constant, we can find the system is time invariant. If the resistance R changes with time, its value is R of t, we can find the system is time variant. In summary, a resistor is a time invariant if the resistance R does not change with time. Similarly, we can determine the time invariant property for the capacitor system. If the capacitance C is a constant, we can find the system is time invariant. If the capacitance C changes with time, its value is C of t, we can find the system is time variant. So, a capacitor is time invariant if the capacitance C does not change with time. Similarly, we can now the inductor is time invariant if the inductance L does not change with time. According to the discussion, we know all the electric systems consisting of the RLC, which does not change with time, these systems are time invariant. For example, these systems are described by this equation. Let's determine its time invariant properties. According to the definition we have now, if the system satisfies this property, the system is time invariant. For the first system, if the input signal x of t is time shifted by T0, we can get its output signal is also time shifted by T0. So the system is time invariant. For the second system, when the input signal is time shifted by T0, according to this equation, we can get this result. This doesn't equal yt minus T0. So the system is not time invariant. For this system, when the input signal is time shifted by n, according to this equation, we can find this result does not equal yk minus n. So the system is time invariant. Generally, if there exists the variable t or its function except x of t for the continuous time system, then the system is time variant. For this system, there are function of t, so the system is a time variant system. For this system, there are another variable k except x of k, so this system is a time variant system. Now let's determine the time invariant property for the integrator and the unit delayer. First, for the integrator system, if the input signal is time shift by T0, take this signal into this equation, we can get the result. The output signal is T minus T0, so the integrator is a time variant system. Similarly, for the unit delayer, when the input signal is time shifted by K0, take this new signal into this equation, we can get this result. It equals yk minus k0, so the unit delayer is a time invariant system. Now let's discuss the causal system and the non-causal system. If the present value of the output signal depends only on the present or past values of the input signal, the system is termed as causal system. In other words, the output signal of the system does not advance the input signal. Here is some demonstration in graphical way. For the input signal, its start time is 0. Its output signal, for the output signal, its start time is 0. For this output signal, its start time is greater than 0. So the system is a causal system because the output signal does not advance the input signal. For this system is a non-causal system because its output signal advances the input signal. This discrete time system is described by this difference equation. Let's determine its causality. The answer is a causal system. You can think it after class. Now let's discuss the stable system and the unstable system. If and only if every bounded input of the system results in a bounded output, the system is termed as stable system. We can describe it in graphical way. When the input of the system is bounded, the output of the system may be not bounded. The system is termed as unstable system. We can describe it in graphical way. For example, if the system is described by this equation, show the system is unstable. Assume the input signal x of t is bounded. We can express it in this equation. We can find the absolute of y of t equals this result. We can find when the input signal x of t is bounded, the output signal y of t diverges for increasing t. So the system is an unstable system. We have discussed the time invariant system and time variant system, and causal system and non-causal system, stable system and unstable system. That's all for today. See you later.